So the first thing we need to do is the expected value of y. Now, we've done that before, and the formula is a different part of the formula sheet. So what do? You go 10 times 0.4 plus 20 times 0.5 plus 30 times 0.1. So it's that times that plus that times that plus that times that. Okay? So that's the expected value of y. Now the variance of y. Now with that was, first you've got the expected value. So did anyone work that out? Say again. That's 17. So let's go the value of y less the expected value of y. So that's going to be -7. And this is going to be 3. And that's going to be 13. So that is the distance between the mean and the value. So we need to square that. So we're going to have -7 squared is 49, times it by the probability of that happening, plus the 3 threes are 9, times by the probability of that happening, and plus 13 squared times 0.1. Now let's just check that formula. Whoops. So here I have got the formula from the formula sheet, and I'm going, the standard deviation is the square root of the expected of the value less the mean squared times the probability of it. So in order to get the variance, which is standard deviation squared, that's all I need to do. Okay? Now remember the other way of doing it. Can anyone tell me?
Other way of doing that.
The expected value of y and the variance of y. What was the way we did yesterday? Calculator. Okay.
Well, yes, I'm putting the stats.
Yeah. So do you want me to do that now?
Yes,
Okay. So I need the calculator. So I grab my calculator. Copy that.
Sweet.
And then I go menu and I go stats. And then on my list 1 I've got the y's, which are 10, 20 and 30. And on list 2 I've got the probability of them happening, 0.4, 0.5 and 0.1. And then I go calc, right? I go set and I make sure that the frequency is in list 2, because our frequency is our probability, if that makes sense. So now we can go 1 var, and we have got 17, which is our mean. That's correct. And then here I've got 6.4. So let's then go back to our menu, back here, and try 49 times 0.4 plus 9 times 0.5 plus 13 squared times 0.1. Oh, what did I do wrong? Where did I get 41 from? Yeah, I've done something wrong here.
I think you did, Miss.
What did I do wrong?
I can't remember.
Okay.
Did you make a video on this?
Okay, so entering the correct numbers, we actually get 41 here. So when we've got that 41 for var, we then take the square root of it to get the standard deviation. So the standard deviation is 6.4. So standard deviation of y is 6.4. And that's what we got with the calculator version. So that's sweet. Okay, we're good? Yep? Okay. So then moving on, how do you get expected value of 4y? You're using the formula here, which the expected value, like that, b is 0, so it's a times the expected value of x. A is 4, so it's 4 times the expected value of y, which equals 4 times 17. Okay? Cool? Now the var of y. So we go 4 squared var of y. Because your formula, okay, your formula for var is here, rectangular selection, so we grab that. Okay, let's just put that down here so we can see it. So you basically, your b is 0, a is 4, so it comes to the front and it's squared. Okay? Standard deviation of 4y is the square root of the variance of 4y. Okay? M.
M is the 17 Amos.
Oh, here.
Yeah.
Oh, that equals the expected value of x. Remember, if you don't know the expected value, you use this, and when you do know it, you use that. It's a symbol for the same thing. Okay, population mean. So those are the same thing. Good question, by the way. Good question. So are we all good there? Nice. Yep.
Could you explain the working behind that one? Var for y.
This one here.
No, the one above it.
This one here.
Yeah.
So what happens basically is the 4 comes to the front and is squared. This is the rule that you're given. The proof is in Sigma book somewhere. We're not worrying about that today. So it's ax plus b here. So the a is coming to the front and squaring, and the b disappears. But we have no b. So
Is
for
that just a general rule for what you would do for that?
yeah, so if I just give that rule, okay, that rule here, here's some examples, okay? So if I said var of, oops, get the right brackets, I'm bad like that, 3x minus 10, that would be 9 var of x, okay? If I had the variance of 5x plus 276, that would be 25 times the variance of x.
So it'd be always just
Always this a comes to the front and is squared, yeah? And the b just disappears.
yeah, but
Because it's a measure of spread. So if you had all these things spread out here, if that was my data, if I basically got that data and moved it up and down, I'm not changing the spread. Does that make sense?
right.
So the whole plus,
The plus and the minus.
minus 10 or plus 276 is not affecting spread.
So like this is effectively moving like one group without actually like altering the spread or shape of it.
That's moving it back and forth. But this one here is multiplying it. So if I multiplied that by 2, it would actually, I can multiply it by 2, I can show you. If I grab that and I go Control C, Control V, and then I resize it and do it to 200%, okay, then my dots are going to get bigger too. But can you see that what's happened with the spread?
Yeah, so is that what this is doing?
So that's what, yeah, when you're doubling it, what's happening with the spread is it's actually going, instead of 3 times as much, it's actually 9 times the spread.
Yeah, but that's what this equation is doing, right?
That's what it's all about, yeah. Yeah.